Hi everyone! In this video we will simplify square roots with the product property. Simplify the square root of 128 r to the 21st s to the 15th. 128 has a perfect square in it, but it itself is not a perfect square. It's actually 64 times 2, and 64 is a perfect square, so we can break it into two factors. If we didn't know that 128 was divisible by 64, we could go ahead and check all of our perfect squares. So let's go ahead and start with a list of perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 8, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169, 14 times 14 is 196, and 15 times 15 is 225, and we can stop there. This is always good to have this list next to you when you're doing the simplifying square roots, just so that you can have a list of your perfect squares close by. Now we could go ahead and take 128 and try dividing it by these perfect squares. And moving forward, it will be divisible by 4. It will also be divisible by 16. So just keep going until you know that you have no more to go. In this case, 64 times 2. So we're going to pull these out, 64 and 2. Now we can worry about the variables. Since these variables have exponents that are odd, it means that we're going to have one left over, because we need a square root, which means I need an even number of these to be paired together to make a square root. I'm going to have to break them apart. So I'm going to have r to the 20th times r to the 1st, because I add the exponents, so when I'm multiplying, so this would be r to the 21st. And the reason we do that is because I'm looking for a square root, meaning I need pairs of the variables to be a perfect square. And when I do that, I will divide the exponent 20 divided by 2, which gives me r to the 10th. And with the odd numbers, we won't be able to divide those. Same with the s. We need to divide it into 2, so we have s to the 14th, and then we have s to the 1st, because 15 is 14 plus 1, and the 14 is even, so it's divisible by 2. So we can go ahead, let's go ahead and do that one right now, because I'm looking for a square root, and there's 14, and I need them in pairs, meaning 2 of them to be part of the square root. 14 divided by 2 gives me s to the 7th. Now the r to the 1st power and the s to the 1st power do not have a pair, so they're going to have to stay under the radical. Now I can go ahead and simplify. The square root of 64 is 8, and the square root of 2 is not a perfect square, so it also needs to stay under the radical. Now I can combine all of those that came out of the radical out to the beginning, so I have 8, r to the 10th, s to the 7th, and all of those that remained in the radical, they can stay in together, 2rs, and now we've simplified this square root with the product property, and we're all done.